Now here the question is, if the complex number z is such that mod z minus 1 is less than or equal to 1. So we have coordinate axis and then we have a circle whose center is at 1 and whose radius is also 1. So we are talking about all the points on or inside this circle. Now this point is 0 and this point is 2. Now the second one is mod z minus 2 equals 1. So this again is a circle with center at 2 and radius equals 1 unit. So all the complex numbers which satisfy both these conditions are this portion of second circle which lies inside or on this first circle. Now we know that maximum value of mod z will occur at this point. So this is maximum value of mod z. Now we drop a perpendicular. This is 1 unit. This is radius of this circle which is 1 unit and this length is 1 by 2. So we can find this d. This d will be under root of 1 minus 1 by 4 and it will be root 3 by 2. Now we can find maximum value of mod z. Now this is d and this length is 1 plus 1 by 2 and it will be 3 by 2. So this mod of z max square, it will be 3 by 2 square plus root 3 by 2 square. Now this is 9, 9 plus 3, 12. 12 upon 4 is simply 3. So the maximum possible value of z square is 3 and that's your answer to this question. Now we need to find mirror image of this curve given by argument z plus iota upon z minus 1 equals pi by 4 in the line y equals x. Now what we are given is, we are given argument of z plus iota upon z minus 1 equals pi by 4. Now we can write this as tan inverse y plus 1 by x minus tan inverse y upon x minus 1 and it will be pi by 4. Now we'll use tan inverse a minus tan inverse b. We can write tan inverse y plus 1 upon x minus y upon x minus 1 upon 1 plus y plus 1 y upon x into x minus 1 and it is pi by 4. Now we'll take tan inverse to the right hand side. We can write xy minus y plus x minus 1 minus xy and it will be equal to x square minus x plus y square plus y. Now this xy will cancel. We can write this as x square plus y square minus 2x plus 2y plus 1 equals 0. Now center of the circle is at 1 comma minus 1 and its radius will be 1 unit. So it will be this circle. This is 1 comma minus 1 and radius is 1 unit. Now we have to take reflection of the circle about y equals x line. So if we take reflection of the circle about y equals x line, now for this new circle, center will be at minus 1 comma 1 and radius will be 1. Now for this given circle, this point of contact is minus iota and 1 and for this circle contact is minus 1 and iota. So it has to be argument z minus iota upon z plus 1 equals pi by 4 and that's your option C. Suppose z is such that argument of z plus iota upon z minus iota, it lies between pi by 3 and 2 pi by 3, then locus of z is shaded region in adjacent figure. So we need to draw this shaded region. Now if we look at argument of z minus of minus iota upon z minus iota and it is equal to some angle alpha we know that this represents portion of a circle with chord passing from iota and minus iota and making an angle alpha. So what we'll do is we'll draw the axis and then we have 2 points, iota and minus iota. Now we consider a circle passing through iota and minus iota. Then at any point z, this is z minus of minus iota, z minus iota, and this angle will be alpha. Now it says this angle, it must lie between pi by 3 and 2 pi by 3. So we have to draw this region. Then we have to draw two circles. First circle in which it makes an angle pi by 3, and then this second circle at which it makes an angle 2 pi by 3. This again is iota, this is minus iota, this angle is pi by 3, and this angle is 2 pi by 3. So we need all the points z such that this argument, it always lies between pi by 3 and 2 pi by 3. That means we are talking about the region in between these two circles. So the locus of z is represented by this region within these two circles.